A stone falls vertically downwards through a tank of viscous oil. The speed of the stone as it enters the oil is 2 meter per second, and at the bottom of the tank it is 3 meter per second. Given that the oil is of depth 2.4 meter, find the resistance F newtons that it exerts on the stone whose mass is 4 kg. Okay, take G equals to 10 meter per second square. Okay, so now V here equals to 3 meter per second, and over here it's 2 meter per second. Okay, since it's acting at a certain height starting from 2.4 meters, so there will be potential energy involved because there's a certain height involved over here, so which is 2.4, the height is 2.4, and since there's a movement, it's going down through the viscous oil. Okay, there's kinetic energy as well. So let's find out what is the initial ME. Okay, the mechanical energy, PE plus KE. Okay, what's the potential energy? mgh, then plus half times by mv square. Okay, mgh we have 4 kg times by 10 times by the height, which is 2.4 meter, plus half times by m, which is 4, times by velocity as it enters, it is 2 meter per second square. Okay, so use your calculator to find this. That's 40 times 2.4 plus 2 times by 4, so that's 104 joule. Okay, so that's the initial ME. Okay, next the question here, find the resistance F newton that it exerts on the stone whose mass is 4 kg. Okay, there's a certainly as it goes through this viscous oil, there's definitely a resistance. So resistance will try to slow down. Okay, but as it goes down, it might not be 3 meter per second. Okay, it could be higher than 3 meter per second, but due to the viscosity of the oil, the resistance, the speed is just 3 meter per second. Okay, so now work done by resistance is actually the difference in the ME. Okay, so I have to find what is the final ME. Okay, mechanical energy. So at final ME, there's no height. No height. So when there's no height, therefore no mgh. Okay, which is no PE. Okay, no potential energy involved. So what's left is just kinetic energy. So let's find out what is the kinetic energy. V square. So over here we have half times by 4 times by 3 square, and the answer is 2 times by 9, which is 18 joule. Okay, so we have initial, we have the final. Now what is the difference between them? The difference is 104 minus 18 joule, and the answer is that's 86 joule. Now resistance is actually an opposing force. Okay, the force that works the force that it works to reduce the movement of the stone. So there's a force which is resisting for resistance. Okay, this force, what happened is this will reduce the final ME of the stone. Okay, or the final ME. That's why you have here 18 joules. Okay, so there is a resistance certainly. So we have to find what is that resistance. Okay, so work done, okay, by the resistance is equal to the resistance force, okay, times by the distance, and we can see that it has reduced drastically. Okay, 104 minus 18, and now it's 86. So this 86 is the work done by the resistant, equals to the resisting force multiplied by 2.4, which is the distance. So from here, the resistant force RESISTNCE, resistant force equals to 86 joule divided by 2.4, and the answer is 35.8 Newton. Okay, therefore the resistance is 35.8 Newton.